Welcome to another episode of the Azure SDK Community Standup. Oh, I'm having camera already. Give me 1 second. Let's see. Let's change the camera. All right. Well, I guess we're gonna have to go with this camera today. You know, going live, it always something's about to happen. But anyway, welcome to another episode of the Azure SDK Community Stand-Up. My name is Hector Narzagaray, and I'm a product manager for the Azure SDK team, and I'll be your host for today. It's awesome to have you here as we chat about some of the cool new releases we've been working on over the past few months. We've been super busy adding new features and making improvements, and we can't wait to share what we've been up to. We think you'll love these updates and find them really helpful for building better, faster, and more scalable apps. Today, we will focus in one of those releases, and we've got a really exciting topic. We're going to be talking about building intelligent web apps with the AI chat protocol library. And to help us dive into this, we've got a special guest, Rohit Ganguly, joining us. Rohit is a product manager for the AI chat protocol for the Azure SDK team, and will show us how to use the library to create smart web apps that can really enhance user experiences. Before we jump in, I always like to start by introducing the Azure SDK PM team and the product managers that are working in some of the services and some of the languages that we have SDKs for. For example, here you see the Python SDK and the storage, machine learning, and Microsoft AI chat protocol. PM, it's Rohit, who will be joining us today. And then I'm here with JavaScript, TypeScript, SDK, AI search, which it has a lot to do with the topic from today. Let's move on from that. Always feel free to contact these people if you have any issues with any of these services or any of these SDKs. We'll be happy to talk to you. There's ways to reach out to us, especially through social media, and we can help you. Or we just want to hear what you think about the products that we work on. So for today, what's new in Azure SDK? We're gonna let you know that you can always go into the releases. You can go to the Azure SDK blog every month, and we not only show what releases we had for initial, for stable, for betas, and all of that, but we also publish a lot of the demos and documentation and stuff in there that it will be very helpful for you to see. Um, so for the last for May, we did a lot of work in Dev Center, Application Insights, front door support for Java, JavaScript, Go, and .NET. And then we have initial and beta releases for May for Java, Go, .NET, Java, JavaScript. Like I said, you can always go to the Azure SDK blog and just check that, the change logs and more information about that. In June, we had event grid namespaces for .NET, Java, JavaScript, text translation, also for all of those languages. But I'm not going to go too much into detail because one of those releases was AI chat protocol. So I'm going to bring Rohit into here. Hey, Rohit.
Hi, good to see you.
Good to see you too. It was bound to happen. We practiced this, and then the camera didn't work, and I had to change cameras last minute. But you know what? Good thing we were prepared for this. How are you?
Doing great. Thanks for having me. I'm excited to chat more about this.
Yeah. So why don't we get into this? What is AI chat protocol, and why are we so excited about this?
Sure, let me jump into these slides and we can chat more. So before we jump more into what specifically the AI chat protocol is, I kind of just want to talk about AI applications. And before I want to talk about AI applications, there's some terminology I want to cover first. So in terms of the basics of talking about language models, you might hear three words that come up. So I just want to chat more about them. First, we have embeddings, then inference, and completions. So I'll get into more of them. So what are embeddings? Embeddings essentially are a vector or dimensional representation of semantic meaning. That's a lot of words. What does it actually mean? So let's start with semantic meaning. That essentially means what a word is in terms of the relation to other words. So, the way that dog and puppy are similar words, those have semantic similarity. And getting into a vector and dimensional representation, that's how computers can understand the way that we have words and relate to them. That's essentially putting them on a map in many different dimensions and saying, for example, dog and puppy are close. Those are similar words. Dog and cheesecake, on the other hand, would be further away. And language models have essentially taken these words, embedded them, and then now have a way to relate between different words. And I can understand how to put together sentences this way based on the meaning of different words. The next term is inference. So what is inference? So the word inference comes from the word infer, or kind of predict what's next. In other words, this would be calling the model, because the model has been trained to predict language or output language. Lastly, we have completions. What are completions? So that is exactly what a model generates and returns. So for example, the completions that you receive would really depend on the instructions given to the model. And this is usually done by passing in a system prompt. In a conversation with a model and a user, there's the user, who would be me chatting with the language model. There'd be the assistant, which is the model itself. And then there's the system. The system essentially is, you can think of it as like the boss of the model. This is what tells a model what to do. So if I tell a model, talk like a pirate, then this will be the instruction the model receives, and that will impact the completions or the output that it gives back to me. So for example, if you use ChatGPT, ChatGPT is designed to provide completions for questions in a friendly/assistant tone. So these are the three terms that you might hear come up: embeddings and also vectors. Embeddings, again, just the meaning of the word that a computer can understand. Inference, just you can think about it like just calling a model, asking it to do something. And then completions, those are what the model returns, which is the completions to the prompt that it's given or the instruction that it's given. We can jump into a really basic AI scenario here. And I want to emphasize that this is an incredibly basic AI scenario. I wouldn't recommend this for production. I wouldn't even recommend it to test it out. This is literally just the most basic thing you can do if you have something running in a web app and you want to get the output to your computer and print it out in the console or render it in HTML, whatever you want to do. So let's first say you have a device running a web app. This web app will use an Inference SDK. Again, an Inference SDK just calls the AI models that you want to use. So on Azure, we have a few options. You can first use the Azure OpenAI libraries. Again, we don't recommend doing this on the front end. This is a more of a back-end library that you want to use. We also just released...
This is a real hello world, just to see it working.
Yeah, exactly. Yeah, very basic hello world scenario. Essentially just talking about the simplest way you can get AI output to a browser. Again, don't do this in prod. Don't do this for anything, because this does require API keys, and you don't want to be putting API keys on the front end. But in terms of a simple example, this is what you could do, hypothetically. So we can use the Azure OpenAI library. We also have the new AI inference library that came out for JavaScript and Python. So for JavaScript, you can run this in the, JavaScript runs in the browser. So you can have this library running in the browser in this example. Then you can send a call. So you can send something like hello world. And what do you talk to? You would talk to some AI service. So for example, on Azure, you can use Azure OpenAI service to talk with GPT or OpenAI models. And then the model would return a completion. So it would return, hello, how can I assist you today? For example, if you passed in no other instructions, because that model has been trained to be a helpful assistant. And one thing to note here is that you can have streamed or synchronous responses, meaning in JavaScript, you can kind of have a for await, meaning you have an asynchronous for loop kind of handling and rendering the output of the model in real time or streaming it to your front end. You can also have this synchronous, meaning that you get all of that response at once. It depends on the way that you call it. This is an important note that you want to have, because when you're chatting with an AI, when you have an AI chatbot, having streamed completions is helpful, because it kind of lets the user read the output in live time, and it also feels more of like an actual user is typing back to you. And also, you don't have to wait too long for your response. So streaming is one nicety that is important for AI applications, and that's what the AI chat protocol helps with, but more on that in a second. This example that we showed is very, very simple. And you might be thinking, obviously I have ChatGPT, I have so much. Having just a simple inference call with no extra steps or extra, special sauce is not too intelligent. It's something that we're used to by now. So you might be wondering, how can we make it more intelligent? And there's a few ways. First, we can look for model improvements. So how does the model improve over time? So for example, GPT 3.5 versus GPT 4.0 are going to be very different in terms of the output that it has. So that's how intelligence can be improved in one way. Next, you can also give it access to your own data. So for example, if I have documents like HR documents and I want it to be like an HR assistant, we can give it some extra data for it to look through and provide in its responses. Next, we can also have AI orchestration frameworks, and I'll dive into more of these in a second. Starting with model improvements. The new models actually have what's called function calling, which is great. It can promote agentic behavior instead of just being a language model that just does something and that's it, or that provides completions and that's it. So for example, during setup, I can tell my model, hey, here's a bunch of functions. And this is one function, for example. I have a function called get weather, and it takes in a city name. And then the next time a user will say, hey, what's the weather in New York City? Then the model can realize that there is a function called get weather. It can then realize that it takes in an input for a city, and then it knows how to return output that passes into this get weather function. Meaning that instead of just having a completion get called, it can also understand functionality to call when it receives a certain response. This is what promotes more of an agentic function as opposed to just a chat completion. Because now your applications can do a whole lot more than just besides returning text, for example. The next way we can make our model or make our applications more intelligent is by giving access to our own data. So we can give it documents, for example, that it can search and provide answers on. And the way that we would do this is through vector stores. Remember that models speak vectors. This is kind of how they, vector embeddings. This is how they understand the language that we provide it. So when we provide our own documents, we can use a vector store to kind of translate it to the language that the AI will understand. This process is known as RAG, or retrieval augmented generation. Retrieval meaning it goes to the documents and retrieves it. Augmented just means it enhances it. And then generation is what these models do. It generates text. So the generation of the text is enhanced by the retrieval of the documents that it looks through. Again, remember, these language models understand language through vectors. So these vector stores are helpful. And on Azure specifically, you can use Azure AI Search, or you can use Azure Cosmos DB for PostgreSQL with PG Vector. There's guides on this online, but some of our samples as well discuss this, and we'll jump into that. Lastly, you can use AI orchestration frameworks. So these are essentially abstractions for function calling, RAG, and more. So instead of having to worry about handling that code directly by yourself, you can use something like semantic kernel or LangChain to easily look through documents, do function calling, and kind of understand just semantic kernel, and underneath, you don't need to worry about what it's doing underneath, and it's just a simpler, more application developer-focused workflow to understand. The key thing to note here is that these frameworks aren't mandatory, but they just provide an easier way of doing things if you prefer to have some sort of layer on top of that. So we can jump back into our very simple example. And now we know it's simple, but it's not very intelligent, and it's not really helpful for business uses, right? One thing that we can do here is that now that we have other pieces to interact with, the inference does not need to be on the client side anymore. We can move the inference to the backend and then integrate it with business logic. And we can jump into an example for that. Here's a more realistic AI scenario. So we have three pieces here now. We have the client device, or your computer running the web app from the first example. We can call that just the front end. Then we have an API endpoint that your front end will talk to, the same way that a client and a server interact with each other in a web app. This endpoint will also interact with your AI model service. So for example, here, Azure OpenAI service. That icon on the API endpoint is semantic kernel. So this example, we're using semantic kernel to orchestrate all of the different decisions being made and the agentic logic of your AI backend. We can kind of group the endpoint and the AI model service as an AI backend. This is kind of where all of your AI logic happens: your inference, your retrieval augmented generation, your orchestration, function calling, and so on. The key thing here is that the client and the AI backend are separate here. And this clean separation allows for your control over your requests and responses. It allows for secure credential management, allows for performance and efficiency. You can cache things. And also, again, that same client and server business logic separation that you're used to in your applications. Let's jump into an example now. So I can ask a scenario, for example, if I train this on, or if I passed in documents on our HR policies, I can say, hey, what is the match on our 401k? I'll send that over to the API endpoint. And then the API endpoint can use different vector stores. It can use AI search, for example. So maybe it checks AI search. Or maybe it uses Azure Blob Storage to retrieve a file, then use AI search to be able to semantically look through it. Then it'll call the completions. on Azure OpenAI service, and then it'll get a response. And once it gets a response, then it can send that response back to the client. Now, there might be something missing from that first example that we mentioned earlier. And you may be thinking, where's our streamed responses? And that's exactly where the AI chat protocol comes in. You see here, now that we have an extra step where we don't directly call inference, we actually need to pass something back to the user in a way that they can see it in live time. And also for a front-end developer, we need to do something that helps them render things in an easy to understand way, because there's a lot of AI logic here now. That's where the AI chat protocol comes in. So in between the client device, which is running the web app, and the API endpoint, there is an API spec that the API endpoint is running, and also a library that the front-end code is using. This is, oh, the lights just went off in here. Oh, one second.
I love live sessions.
How fun is that?
Wait until we run code, but anyway.
Right. So yeah, we have the AI chat protocol, which sits in between the API endpoint and the front end here. So this allows for easy streaming to your front end. We can talk more about that. And that's essentially the introduction to the AI chat protocol. So I mentioned there's two pieces. There's an API spec and a library. So the API spec is essentially just a standard interface for your AI endpoints for consumption and evaluation. So if you have an AI backend with a bunch of different steps, it's just a consistent interface for sending that output back to the front end. It essentially defines the front end behavior that you want to have. The key thing here is that it comes with interoperability by default. Since it's an API spec and nothing more, this can technically be fit for any sort of AI backend that you have. So for example, if your AI backend is using orchestrations or not, if it's doing RAG or not, if it's doing function calling, there's a bunch of different logic there. It doesn't matter because the AI chat protocol is simply a way to define how that gets sent back to the front end. And it's very flexible and very interoperable. In terms of actually developing on the front end, the library that we use is the AI chat protocol library is an easy to understand JavaScript library for consuming those AI backends. So now that you have an API endpoint, the library knows what the API looks like underneath, and you get a lot of benefits out of the box. It comes with a lot of the benefits you might be used to with our Azure core libraries. So our HTTP client lifecycle, our logging and tracing and auth, all of these things you can configure with Azure core are available in this library as well. And most importantly and most relevantly for AI applications, there's support for streaming responses right out of the box. So it's almost like you're calling inference in the browser, except now you're actually doing it with best practices and you get all the niceties that you would in a really easy to understand way for streaming generative AI output to your front end. So going into the API spec, what does that look like? If you want to learn more about it, you can go on aka.ms/chat protocol, but it's really simple. There's a certain way you can request it, which is listed in that URL, but our responses are kind of more relevant here. So we'll talk about that. How do you design that API? How do you fit that API spec with your application to the front end? There's two responses you need to have. There's a non-streaming response, which will return all of the generated output at once, like a synchronous call. The content type will be application JSON, and it will contain a message, which is required, obviously. If you want to send something back, it should have a message. You can also have a context, which you can pass in. And the key thing with the context is that it's application dependent. So it's not required, but if you want to send any extra information back to your application, for example, if you want to send in how many messages you have left, or if you want to send in any other information about the session to the front end for it to be rendered or handled in that front end logic, you can. So it's very flexible again. And also you can send in the session state. Similarly with the streaming response, it's essentially the same thing, but it's asynchronously returned and it's generated via stream. So the content type here would be application/JSON-L. JSON-L is just JSON lines or lined and delimited JSON, just essentially a JSON response line by line. And similarly, each object would contain a delta, a context, and a session state. The delta is not the full content, not the full message at once, but it's part of it. So it essentially is that part of the message to render in the front end while you're waiting for the other pieces to arrive. This allows you to generate the output as it comes back to the front end and doesn't make the user have to wait for a large spinning cycle just to get the message back. It makes the responses feel a lot more natural. And that's kind of the niceties of having this library. You can easily do that because when you're passing JSON back and forth, there's a lot of parsing and whatnot that makes it tricky. From here, you can just easily have streaming to your front end as long as the back end adheres to that API spec. And the beauty of it as well is that it doesn't matter what backend it is. If you have a Python backend, if it adheres to this API spec, you can also stream to the front end. It can be any language, it can be any orchestration framework, it can be any sort of process in between your inference. So, RAG, function calling, things like that. It's all very flexible for your AI apps. This essentially just is defined behavior to stream to your front end. In terms of how the library would look in terms of usage, so first you'd want to install the library via Node Package Manager. So that would be at Microsoft/AI-chat-protocol. Once you have the library, then you want to instantiate a client object. And if you're used to the Azure SDKs, which I'd assume you are, it's very similar to how you use it. So we have a client where you pass in, you can pass in a credential optionally, you can pass in the endpoint where you need to stream from, or the endpoint you want to call inference from. And then you can pass in some options. So that's the AI chat protocol client. And similarly with the Azure SDKs, once you have a client, now you can do something with it. So we have two methods for that client that will be most relevant for completions. We have get streamed completion and we have get completion. It's kind of just exactly what it sounds like. So get completion is an asynchronous all at once message received from the AI backend. And get streamed completion is an asynchronous streamed completion that you can then render delta by delta on your front end. And when you call this, it means that you can have like a for await loop, which we'll get more into in the code samples and also the demo. And this just makes it really easy to understand. Speaking of demo, here's just a high-level architecture of what the demo looks like. This is what we talked about at Microsoft Build, and I'll link to it at the end, of course. But essentially, we see this application design. We have a static web app, which calls Azure Functions, the serverless API. The serverless API can then call Azure OpenAI Service for embedding text chunks and generating the answer. It can then use Azure AI Search for storing those text chunks and retrieving them with the vector search. And then Azure Blob Storage, where it can retrieve a PDF and store PDFs. So we can pass in those files, and then this application will embed them, store them, and then we can retrieve them later on in the conversation. So that first call might take a little bit just for all of those pieces to run together. But after that, then we'll have a nice embedding stored in Azure AI Search, and then we can search with it. And the key thing to understand here is that with this web app, we have an HTTP call to our serverless API. This API adheres to the chat protocol API spec, meaning that we can easily stream that output back to our front end, and it comes with a really nice, easy-to-use JavaScript library. So let's jump into the sample, and I can show you some of the code. First, we have the AI chat protocol GitHub repo that you can access that at aka.ms/AIChat. If you're curious about that and want to check out the link, please star our repo. We're almost at 100, getting really excited about it. So yeah, check it out. When you go down here, you can see kind of the high-level overview of the AI chat protocol. It has the SDK or the library you can use. Then it has the API specification, if you're curious on those. Again, the API specifications, aka.ms/chat protocol, in case you wanted to read up on that. Then we can get into our getting started, and it looks a lot like what you might have seen on that slide already. So we get our npm install. We can then create the client object here. And then in terms of how we actually stream completions to our UI, we can pass in a chat message where it has the role and the content that we pass to the backend. Call get stream completion, sending in that first message. So it'll say hello world. And then we can have a for await loop in JavaScript, which is great and nice to handle things as they arrive. And then we can see that there's a session state. Maybe it has the role of the message, and maybe it has the content. We can do something with the content, role, or session state, depending on what gets returned. And jumping into our sample here, we can go to samples on Azure, or just regular samples, which you can run locally. But samples on Azure, for example. Then we have this first one, serverless AI chat with RAG using LangChain.js. And that's a sample we'll talk about today. So going into that demo here, I have it all in a GitHub code space. So getting, let's see, it's a preview here. Oh, I already have the preview pulled up, 1 second. So this essentially is a full demo you can run using the AI chat protocol library on the front end, and then that same application architecture I used earlier that uses retrieval augmented generation. So the way that you could run this locally, if you're curious, is by using the Azure Developer CLI. And that is essentially a really easy way to spin up and tear down resources and run samples on Azure that we provide. So going into the examples, once you have things open in GitHub on your local machine or on Codespaces, which is like me right now, then you can get the Azure account, you get your subscription with Azure OpenAI enabled, and then you can run Azure, AZD auth login to first log in to Azure, make sure that Azure knows who you are, and then we can run AZD up. And AZD up will deploy and provision all the resources you need for the sample. So it'll make sure that your storage account's set up, it'll make sure that your Azure OpenAI service is set up, it'll make sure that your Azure AI search is set up, and kind of all the application logic and the application itself being deployed. And once you have that, then you can now mess around with the sample. So if I go in here, then I can run a bunch of, I can ask questions about the documents that I sent in. And this is all on, mock company data, so you can kind of adapt it to your business use case. So I can say, how to search and book rentals. Be thorough. And the reason why I'm asking it to be thorough is because I kind of want to show the streaming to your UI in live time with the chat protocol library. So I can send that. And like I said, it needs to take the files, it needs to embed them so the AI can search through it. Then it will use AI search to look through the documents and perform retrieval augmented generation. And then lastly, it will stream the output to the UI with the chat protocol library. The nice thing about the chat protocol is that it cleanly separates all of this logic. And you can see all of this stuff is getting streamed to the browser in live time. And these little pauses here are actually because we have responsible AI on, meaning that it's checking the output to make sure that your users are receiving something that is proper and not harmful and not hallucinating. So you can see that all of the responses get streamed back, and even add citations. So we can have links to the files that we want to get. So for example, this will be the mock data that we have for Contoso Real Estate, which is our fake company name. Jumping into the code now, we actually have a convenience function around the chat protocol. So first, you can see on line 1, we import the AI chat message, the chat completion delta, and then the client from the Microsoft AI chat protocol library. We have some special logic to handle the base URL, which is kind of from this sample itself, specifically to the sample. We have some chat request options. And then we have a get completion function, which kind of wraps the get streamed completion function from the AI chat protocol, as you can see on line 14 here. So we create our new client. We have the result, which is, again, getting asynchronously getting completions from our endpoint. And then for here, we are essentially ignoring everything that's not a delta, everything that's not a part of the message we're ignoring. And then this is a generator function, so we're yielding this back to whatever calls it. This is part of our API.typespec file. Again, very sample specific. If you wanted to run this directly here, you could. It's just more for code separation and kind of ease to understand. So you can see on line 123 here, we have a few things. So we have the get completion function here where we pass in the options and then the messages history that we have. So then there's some context around the actual conversation that's been going on. And then we have the response as a generator where it takes a generator of our completion deltas, again, the pieces of the conversation that we have. We have our messages, and then we have that message from the assistant, so we can render that on the front end or on the front end from the assistant side. So going back into the sample, this would be the message on the left since it's an assistant message. And then this is the nice part, right? You get all of these chunks, all of these deltas of the message itself. You can just easily asynchronously iterate over them. And then you can just see if it's content, then you can set to any sort of front end logic. So here it sets is streaming, and then it sets the content here. And then there's a nice function, scroll to last message. So then as the response is coming in, it'll automatically scroll down. So if I ask another question, you can see that whatever response is coming back, it automatically scrolls to the bottom here, which is great. So that was a quick demo of the chat protocol library. There's not too much else. I mean, honestly, a lot of the code here is just application specific. And that's the idea of the chat protocol library. We don't want there to be too much to learn. We just want a nice, clean, easy to understand contract for streaming generative AI output to your applications. Let me jump back to the slides. That's all I had, actually. If you want to learn more about the chat protocol, you can go on ak.ms/AI chat. We also have the API spec available in that repo. And if you want to look at it separately, that's aka.ms/chat protocol for the API spec that we follow. We have an evaluation sample as well if you're interested in evaluating your AI output and kind of testing to see how grounded it is and kind of seeing how it does in certain metrics. That's available at ak.ms/azai/eval. And then specifically for this demo, if you're curious on that, that's ak.ms/aichat/langchain.js. Oh, I forgot to mention this sample does use orchestration as well as retrieval augmented generation. So it's a great example if you want to get started. That's all I had, Hector.
This is great. Actually, as a front end JavaScript enthusiast, uh, I'm amazed at how much we can do with very minor difficulty to get into it. Right. I like that we have a bunch of samples. We can to get it started. Right. Like I like the fact that we did this demo in it's going to run in your machine, you can see something doing, and that'll spark. It always happens to me that when I'm getting excited, uh, it feels overwhelming, but then having a clear sample like this one that we literally can get it going within minutes or
Yep.
not a lot of effort, this is great. So I know we have a bunch of resources where we can learn more about this. Thank you for the links. I think the demo, it's great, right? Like we should all try it. But going into, I think it's AZAI, the ak.ms/AZAI. You can see a lot of other things, or a little bit more advanced, or something else. That's very
Mhm.
exciting, and having this much work being put into JavaScript makes me really happy. I happen to be the PM for JavaScript and for AI search, and seeing that it's being used in this way, it's amazing. Now, do you have any future plans for this project, or is this something that you can give us? I mean, I don't want you to tell us everything, but is there something you're looking forward for the next
Yeah.
steps?
Yeah, we have a lot of exciting work coming out with the chat protocol. So as you can see, this was just text-based responses. But in the future, we're currently working on adding file support. So if you want to have files sent to and from your AI backend, we're also adding support for that in the future, which is really exciting. We're also adding more samples in other languages. In our repo currently, we have JavaScript and .NET with semantic kernel samples, but we're also working on adding samples in Python. We're adding samples in Java and so on as well in the future. So we really want to show that the that the AI chat protocol is very flexible across a bunch of different samples, and we want to match your real world scenarios. So we're working on that. And also, you might have noticed that this is a JavaScript and front end library, but we don't have any front end components. So we're working on that right now. We're trying to get front end components for you. So instead of having to focus on that logic yourself, you can literally just import a React component, and it's just a chat bar or something like that that will be really easy to render for you. So instead of having to write things yourself, you can render an AI chat application even faster. So that's what you can look forward to, as well as more samples that are cross language model, cross process. So RAG, different tools, different libraries being used all in the AI backend, since there's so many different types of AI backends you can build. And again, we have one unified, simple way of streaming to the front end. So lots of different samples upcoming.
I really appreciate that. So we always send people to aka.ms AZSDK GitHub. Is this a good repo where they can find this, or do we go directly to the chat protocol one? Uh,
Yeah. So if you're interested in Azure SDK specifically, that link is good, the AZ SDK one. This protocol, you might have noticed there's no Azure terminology around it. It's used in Azure in a
I
bunch of
noticed.
samples, but this is actually a general sample. So hypothetically, you could use it with any sort of generative AI backend. It doesn't need to be on Azure, but we work with obviously with a lot of different samples. And from a best practice perspective, in terms of separations of concerns and also the niceties of streaming to your UI with all of the retries and everything, we think it's a great middle ground for AI solutions, but it's technically not Azure. So if you wanted to check it out, that's aka.ms/AI chat.
Well, and I would appreciate if people go there, take a look at it. We are always looking for people to get involved in these projects. This is open source, so we strongly suggest to go and be part of this, right, and help us. And always feel free to reach out to either Rohit or just you know create an issue there and just like do something to get involved. Also, let us know how you're using this. Like, I want to see how people are using it in real life. We always have an idea of how it should be used or how it could be used, but it always amazes me how people are doing things, right? And we want to be part of that conversation. Um, so don't think there's any Q&A today. That there were no submitted questions. Let me see. Actually, uh, okay. We will be continuing these discussions. I suggest going to the Azure SDK blog to hear more. Rohit has published other things about this, and we're going to continue talking a lot more about this. You can always subscribe to the RSS for the Azure SDK blog. You will see all the releases and the cool things that we're working on. Uh, Find us in Stack Overflow, right? And then just figure it out in there if you have any questions. In general, for the Azure SDK, this is the whole point. Today, we chose a very exciting topic. For samples, you can go to aka.ms slash azai and follow us on X. I should update that. It's x.com slash Azure SDK. And well, that's it for me. Is there something you want to add?
Oh,
Yep,
yeah.
I'm losing myself.
Nothing to add. Check us out at aka.ms/AI chat. Feel free, again, to open issues, use it in your projects. This protocol isn't Azure specific, but it's using a lot of Azure samples. You can check those samples out at the repo. And yeah, thanks so much for tuning in.
Well, for now, we're going to say goodbye, but don't forget to subscribe to the YouTube or Twitch channel and the Azure SDK blog so we can continue showing your light went off again. uh, so you can be on top of what topics we have. And if you have any suggestions, please let us know. If you want to learn more or if you want to have a demo or a conversation with any of the Azure SDK um, Azure SDKs in general with the services or the languages, we'll be happy to see it. But for now, thank you so much, Rohit. Thanks everyone for joining us today, and we'll see you the next one.
Thanks all.